All right, let's jump right in. Today, we're talking about a process you've probably never seen, but that you absolutely can't live without: nitrogen fixation. It's the invisible, all-important chemical reaction that unlocks the very air we breathe to build life itself.
And to really get what's going on, we have to start with a huge puzzle, a real head scratcher that I like to call the Great Nitrogen Paradox.
I mean, just think about this for a second. The air all around you, the air you're breathing right now, it's almost 80% nitrogen. So you'd think it would be super abundant, easy for every living thing to grab and use, right? But it's not. And that's the central mystery we need to solve. And here's the reason why. Almost all of that nitrogen is in the form of N2. That's two nitrogen atoms held together by an incredibly powerful triple bond. This thing is one of the strongest bonds in nature, which basically puts the nitrogen on chemical lockdown. It's totally inert, plants can't absorb it, we can't use it, it's everywhere, but it's completely out of reach. And that's what makes this such a colossal problem. Because nitrogen isn't just some optional extra. No, it's an absolutely non-negotiable ingredient for life. It's in every single protein that makes up our bodies, and it's a key part of the DNA that makes you, well, you. Without a usable source of nitrogen, life as we know it would just grind to a halt. So, from the very beginning, life on Earth needed a key to pick that chemical lock. And that key, that solution, is a process called nitrogen fixation. This is the whole magic trick. It's the process of cracking open that super strong N2 molecule and converting it into a form life can actually use, mostly ammonia. So, how does this incredible unlocking actually happen? Well, it turns out there isn't just one way. Life, and much later human ingenuity, came up with a few pretty clever ways to solve this nitrogen problem. We can basically break them down into three main categories. You've got the natural, biological method. Then there's the artificial, industrial one, and finally, a much more dramatic method that comes from the sky. Let's break each one down. First up, let's talk about the planet's original and still most common solution. This is biological fixation, and it's all handled by some of the smallest yet most powerful organisms on Earth. This is honestly just mind-blowing. The real heroes of the nitrogen story are tiny microbes. These little bacteria have a secret weapon, a special enzyme called nitrogenase, and it can do what no plant or animal on Earth can. It can systematically break that N2 triple bond and combine it with hydrogen to create ammonia. And it's not just one type of microbe either. We're talking about a whole crew of them. You've got some like Azobacter and Clostridium that are free living in the soil. You have cyanobacteria doing their thing in the water. But maybe the most famous of all are the rhizobium bacteria. These rhizobium bacteria have worked out one of nature's most incredible deals. It's a symbiotic relationship where the bacteria actually move in and live inside the roots of certain plants. It is the ultimate win-win partnership. And you see this partnership in action all the time, in plants like peas, beans, and clover. The plant gives the bacteria a safe place to live and feeds it sugars from photosynthesis. In return, the bacteria provide the plant with a direct, on-site supply of usable nitrogen. It's like having a tiny, personal fertilizer factory built right into your roots. So for thousands and thousands of years, all of life depended on these natural processes. But then, just over a century ago, we humans figured out how to do it ourselves, and that sparked a revolution that changed everything. This revolution is called the Haber-Bosch process. It's our industrial method for fixing nitrogen, and it's not an exaggeration to say it's one of the most significant inventions of the 20th century. It fundamentally changed our ability to grow food. So how does it work? Well, if the microbes method is subtle and elegant, Haber-Bosch is all about brute force. You take nitrogen right out of the air, mix it with hydrogen gas, and then you subject it to insanely high temperatures and pressures, all while running it over an iron catalyst. The result? A massive, massive output of ammonia. So the contrast here is just night and day. On one hand, you have biological fixation. It's a natural process done by microbes with a very low energy cost. On the other, you have industrial fixation. It's totally artificial, it's done in huge factories, and it requires a tremendous amount of energy. Two completely different ways to get to the same result. And the impact of this process, well, it just can't be overstated. The ammonia that comes out of these factories is the main ingredient in modern synthetic fertilizers. It's estimated that these fertilizers are responsible for feeding almost half of the entire world population today. Think about that for a second. Okay, so we've covered nature's tiny engines and humanity's massive chemical plants. But there is one more source of fixed nitrogen, and this one comes with a flash and a bang.
I absolutely love this way of thinking about it. Every single time you see a lightning strike, you are literally watching a tiny fertilizer factory at work.
The sheer, raw energy of a lightning bolt is powerful enough to do what seems impossible. It splits those tough N2 molecules right in the air. Those newly single nitrogen atoms then combine with oxygen to form nitrogen oxides. These compounds dissolve in the rain, fall to the earth as nitrates, and give plants another awesome natural source of fertilizer. Now, it is really important to understand that fixation in all these different forms is just the first step. It's just one part of a much bigger system called the nitrogen cycle. Once that nitrogen is fixed, it gets passed all through the ecosystem, from plants to animals and back into the soil, until other bacteria eventually send it back into the atmosphere. It is a continuous, beautiful loop. And this cycle is just a perfect example of the planet's elegance. It's this closed-loop system that makes sure this essential, life-giving element is constantly recycled and moved through the air, the soil, and every living thing on Earth. It's a self-sustaining masterpiece.
But that brings us to our final critical thought. That perfect self-sustaining system has been, well, dramatically changed. The Haber-Bosch process has allowed us to feed billions of people, an absolutely incredible achievement. But by artificially pumping massive amounts of fixed nitrogen into the biosphere, we've thrown the planet's natural balance way off. So the question we're all left with is, how do we manage the consequences and restore the delicate balance that all life truly depends on? It's something to think about.